OSPF is open shortest path first. That's a intra-domain routing protocol which works within an autonomous system. Autonomous system, everybody is aware with that. Autonomous system is a system which is managed by single administrator. Then in OSPF, if you remember, we have seen that autonomous system is divided into multiple areas, where area 0 is a backbone area. So area 0 should be there in the autonomous system, and one autonomous system can have multiple areas. So area 0 is a backbone area. Routers used in area 0, those all routers are known as backbone routers. And there can be some area border router which are, we can say, placed between two areas. So area border router which carries the information or transfer information from one area to another area. So this topology I have completely configured, where I have used only one area, right? So my interest is to show you first that show IP route command, and even I have some topologies which have not yet configured. So that is inter area or different area topology. So here now you are able to see there are how many networks in this topology. There are total 1 2 3 4 5 6 networks. I have given labels here, that is 10 network, 20 network, 30, 40, 50 and 60. So these 4 routers should have OSPF implemented. So I have implemented OSPF. We'll see those commands also. And only one area is used, means all these routers are in area 1. So if you just click on the router and go into the CLI mode, you can see here, this is, as you all know, this is privileged EXEC mode. And just go into the global configuration mode. How to go into the global configuration mode? Configure T or configure terminal. So we are in a global configuration mode. So there you can, if you want to see the running configuration, so come out of this. So this is global configuration. How to come out of from this? That is exit. And now we are in a privileged EXEC mode. So show running config. So you can see here, you will be there. Just wait. First we'll see whether the transmission is successful or not. So it is successful. Okay, it is failed. So via this path, it's a successful from PC to server. It is successful. Just click on any router, then enable, then show IP space root command, that is show IP root. So here you can able to see the routing table, right? Routing table of that topology. So 2 networks are directly connected. CC stands for directly connected. If you observe here in the topology, that network 20 and 30, that is directly connected to router 2, right? And all remaining networks are connected via some network. So that 30, 40, 50, 60, 10, 40, 50, 60, those are connected via some network, that is nothing but exit point. So 20.0.0.1, it is 10 network, 10 is connected via 20.0.0.1, and O stands for OSPF, routing protocol used is OSPF. Now that AD value of OSPF, that is 110. AD value of the OSPF is 110. For RIP, it's 120, administrative distance value. Now this cost calculation that I want to tell you, because metric of OSPF is cost, metric of RIP is hop count. So you can see here, for directly connected, there is no cost required because the network is directly connected. But for 40, 50, 60, the cost varies. See, for 40, cost is 2. For 50, cost is 65. and for 60 cost is 1563. So how that cost comes, that we are going to see. So here OSPF metric is cost. So write down that formula for cost calculation. So cost is equal to reference bandwidth divided by interface bandwidth into bytes per second. So where in our topology we have used some serial interfaces as well as we can say that fast Ethernet interfaces. So fast Ethernet definitely it provides 100 Mbps bandwidth. So cost is equal to 10 raised to 8 divided by interface bandwidth in bytes per second. So in BPS, cost is equal to 10 raised to 8 divided by interface bandwidth in bytes per second. So you can see here default cost of essential interfaces. So interface type is Ethernet link, then fast Ethernet link, serial link. So if the Ethernet link is used, then bandwidth is 10 Mbps. So how to calculate cost? 10 raised to 8 divided by, you need to convert 10 Mbps into BPS. So if you divide that 10 raised to 8 divided by 10 Mbps, that is in BPS, so we'll get cost 10. Fast Ethernet, it's of 100 Mbps. So 100 Mbps is equal to 10 raised to 8 only. So 10 raised to 8 divided by 100 Mbps will get cost 1. For serial link, default bandwidth is 1544 kbps. So 1544 kbps, you convert it into BPS. So 1544 on that 3 zeros. So 10 raised to 8 divided by 1544000 will get cost, that is 64.76. So cost is 64. Right. So here cost of some common lines are given in this table. So line, if the line is 56 kbps, then bandwidth 56 kbps, and the metric calculation is done here, that is cost is calculated 1785. So we can even set the bandwidth to the serial interface by using bandwidth command. We can change the default bandwidth. Default bandwidth to the serial interface, that is 1544 kbps. If we want, we can change the bandwidth, and by using that formula 10 raised to 8 divided by bandwidth of the interface in BPS, we can calculate the cost. So here you can observe in this, for directly connected, no cost calculation. So first we'll see for network 10. For network 10, how the cost is calculated, that is 2. So we are on this router 2. Network 10, which is via 20.0.0.1. So via address will be this address, which is given to this FA0/1. So for this interface, it's a fast Ethernet interface. For this interface, cost will be 1. Yes or no? 10 raised to 8 divided by 100 Mbps. That is 100 Mbps we need to convert into BPS. So that value will be 1. Now this interface is also fast Ethernet interface. So 1 plus 1, the cost is 2. So that's why to the network 10, the cost is 2. Now for this network 40, how the cost is calculated to? By using same methodology. 40 network is here. This is its exit point. So which is connected via 30.0.0.2, right? So that cost is 1 plus 1, cost is 2. Now the serial interface is used. In the case of serial interface, cost is 1562. So that is 10 raised to 8 divided by whatever is the default bandwidth, that is 1544 kbps. We need to convert into BPS, and 10 raised to 8 divided by that value. So that result is 1562. You can see here that, sorry, 64, not 1562. So 1544 kbps, you need to divide into, we need to convert into BPS, and 10 raised to 8 divided by 1544 000, the cost is 64. And if the bandwidth is set explicitly by you, so that I have set the bandwidth for that interface, that is 64, so that is 1562. So you can observe here, this is 60 network, cost is 1563, and 50 network cost is 65. So 50 network, which is also connected by using serial interface, and 60 is also connected by using serial interface. But for this interface, I have explicitly set the bandwidth, that is 64, and this is default. Default is 1544. That's why from this router, cost is 1562 plus this fast Ethernet, that is 100 Mbps, that is 1. So that's why the cost is 1563 here. And for again we'll see the topology. So for 60, even if you want to check the interface, even you can give the command show interface if you want to check the bandwidth of the interface. Show interfaces, or show interface command you can give. I'm not able to maximize it, so just wait. So show interfaces, here you can observe, it will show you all the interfaces details. So you can observe here that bandwidth is 64 kbps. So if the bandwidth is 64 kbps, then cost of the link is 1562. And for fast Ethernet, you can observe here, just scroll up. You can observe here that for fast Ethernet, bandwidth is 100 Mbps. So where we can see the configuration commands also, but now I think because of time we won't be able to see the commands, but still we can try for one topology which I have designed here. Now share the screen again. Now you can observe here that here I have designed one topology where the multiple areas are used and OSPF is not yet configured. So only I think IP I have given. So just to boot this topology, then here OSPF is not configured. So I will tell you how to configure OSPF. Meanwhile, you just draw this diagram where I have implemented two areas. So this middle router, router 5, which is area border router. So router 5 is area border router, router 0 and router 1, those are in area 0, and router 3 and router 4, those are in area 1. So area wise, you can divide this topology. So we'll see. So now I have clicked on router 0. So here we are in privileged EXC mode, then give conf t. So we are in global configuration mode, then give router OSPF 1. So router OSPF, that we are going to specify OSPF routing protocol, and 1 is process ID. So after that, So there must be at least one interface up. So we need to wait till that topology getting up. Still it is not up. I don't think will